Alright, day 24, and it is nearly Christmas. I dare say by the end of this episode it will be Christmas. Never tell me the odds. It seems like something is going wrong with the snowmaking process. Instead of forming snow, the water has been absorbed into the air. It seems like it's forming hail. Maybe there's something you can do to break the hailstones due to strong, probably magical winds. They're flying through their perfectly linear trajectories. I like where this is going. You make a note of each position and velocity. Okay, so XYZ, yep. Each line of text corresponds to the position and velocity of a single hailstone. The position indicates where the hailstones are right now. At time 0, the velocities are constant. 1 nanosecond, great. Each line of text uses format px, py, pz, velocity x, velocity y, velocity z. Great, we have some vectors. Great. Perhaps you won't have to do anything. How likely are the hailstones to collide with each other? To estimate this, consider only x and y axis, ignore z axis. Easier. Looking forward in time, how many of the hailstones' paths will intersect within a test area? The hailstones themselves don't have to collide, just intersect. Okay, nice. In this example, look for intersections that happen with an x and y position, each at least 7 and at most 27. What? At least 7 at most 27. In your actual data, you'll need to check a much larger test area. Comparing all pairs of hailstones' future paths produces the following result. Okay. So in this example, 2 hailstones' future paths cross boundaries. However, you'll need to search a much larger area if you want to see if any hailstones collide. Look for intersections that happen within the x and y corners at least. Oh god. Jesus, that's a lot of numbers. So, I mean, we're not just going to go between them, we're just going to say. Okay. So, we have vectors, and it's an escalator type of day, I think. This is a little bit of, oh look, that kind of helps. We are given an initial position. Yeah, let's go with that. P is equal to xy, and then the velocity is equal to the change in x, so change in y. So that's the velocity. So what we can do, let's say we have 2 of these. We want to know if they intercept. So there's a couple things we can do. Check this stuff out. Right, there we go, our x and y grid. So that is time 0. Let's say that one of our things starts up here or something, goes like that, and we have another thing that goes like this. They will never intercept. But maybe we can get into this, like, we'll never intercept stuff later. We can just check them all. We can check they intercept between that range by solving equations. So we're given an initial position, we're given the velocity, so that's the gradient. So gradient is m is change in y over change in x. If you remember, y equals mx plus c. Well, actually, a much better equation is y minus y1 equals mx minus x1. So we can say, take these x's that we know, substitute m where m is this, and we have a system of equations. So we might have, yeah, we have this. And to kind of see if they intercept, we will have to solve some equations, which I don't really know how to do in code. So first of all, we need to do y equals mx minus m dot x1 plus y1. Okay, that's kind of the first thing to do. and then we make that equal to something else. Like we make that equal to m1. I don't even. I'm gonna get really confused here with stuff. Basically, we want to solve. So, anyways, this here is known. This here is known. So I'm gonna say that minus x1 plus y1 is equal to big A. So y equals mx plus A, and I'm gonna say that's m1. So what we can say is make another equation that's m2x plus big B, where big B is the equivalent for this, and we can join those together, solving the system of equations. How would we do this? Oh wait, we can use. Oh, I was gonna say we can use matrices. We can definitely use matrices, right? Oh god, how to find the inverse of yeah, but that's the part 2 is going to be to find the inverse. So if we have a system of equations that is, God, what was it? Y minus m1x equals A, and y minus m2x equals B. We can make this into the system of equations. The matrix N and xy here is equal to a b, where this matrix is minus m1 and 1. So we get minus 1x and then y, and it's going to be minus m2 1. And then to solve for x and y, the other ones are known, we can say x and y is equal to m1 1, or minus even, minus m2 1 minus 1, the inverse of that's a b. A little bit of fairly basic linear algebra. But yeah, oh, don't mind, maybe I'll face away. This is non-alcoholic. It should be okay on YouTube. It's not. It is alcoholic. Anyways, yeah, and doing this works for 3 dimensions, for n number of dimensions actually. Oh my god, I don't know if I remember how to solve. What is the inverse of 2D matrix? This is something that I don't fully remember. So it is this. Let's take this. So. Yeah, that seems legit. Seems very legit. I think that's right. There we go. So basically we take the discriminant, the something of this, which is going to be minus m1 minus m2, so plus m2. Yep. So that's just m2 minus m1. I'm going to say a minus 1 equals 1 over m2 minus m1, and then we kind of just flip some things over. So this is going to be that one, that's the 1 goes there, the a goes here, minus m2, and then minus b, we just do minus 1 there, and we do minus c m2, that's m1 there. God, let's get rid of that. There we go. Sounds legit. And then doing it for 3 dimensions is a real pain, to be honest. From what I remember, and I will obviously just copy it from somewhere. I do not remember that off by heart. We will do this, and from there we can solve the system of equations, and we can see if it even has a solution, because it might not. And if it doesn't have a solution, oh no, it will have a solution unless they are equal. So actually we need to check this. So if m2 minus if the determinant, I think it's determinant, is equal to 0, then parallel. So they will not intercept. So that's the only check we need to make. Yeah, seems nice. Seems pretty nice actually. So anyway, so let's take the example input. So I'm going to put my drawing tablet away for a sec. Might need it in just a little bit. There we go. First of all, let's start with parsing, and we're going to have systems of equations x, y, z, const line equals structs x. These probably can be negative, so let's go I32. Oh god, I32. Can they represent such big numbers? I32s. No, this is like huge. So I want to wait won't be able to represent that, will it? Maybe it can. Max 2 to the power of 64. And that looks smaller to me than that. So the 128s will be sufficient. X, Y, Z. And we're going to dx, same thing. Z and yeah, I mean we could already calculate some stuff there, but what does my input look like? We're initially going to split on. I think we can just split on spaces, commas and spaces, commas, spaces, and adds. Yeah. So var allocator equals. Can we do the whole thing on how big is the input? Quite big. We can probably do the whole thing on stack allocations actually. No need to allocate anything. Yeah. So for inputs line. Tokenizer equals standard.mem.tokenize sequence. U8 the line and spaces, commas, and adds. While tokenizer.next value. Yeah, there we are. Let's just print. I think that's a string of value. Let's just make sure that we are dealing with the correct thing. Oh, that doesn't seem quite right. What if I just split on spaces? That definitely gives me something different, doesn't it? Spaces and commas? No. Oh. Returns into that turns buffer and sequence delimiters. I guess, but then is there a tokenize any? Yeah, I think it's tokenize any. Okay. Oh, perfect. We don't even want you, so we say x equals tokenizer dot next dot question mark, and we do a try standard dot fmt dot pass int I128. There it is, 10. Ooh, there you go. Y, Z, dx, dy, dz. And we do var line equals line dot x equals x dot y equals y dot z equals z dot dx equals dx dot dy equals dy dot dz equals dz. And we go Actually, we didn't need an allocator. Stand dot keep dot page allocator. We have lines equals try allocator. We're going to allocate a bunch of lines, an array of lines with size input dot length, and we'll do 0, 0 there. We go lines I equals line L. There we go. Anything crash? Nothing crashes. Great. So what we'll have to do is we'll have to check each one as if like each one with each other one. So this one is the boundaries are between 7 and 27. The lower equals 7, higher equals oh god, 18 to 7. So next up, oh god, ouch, just fucking hit my tooth with a ball of it. Oh, ow, that really hurt. Anyways, 0 dot length of not length of, that's go line 1 for line 1 dot lines dot length line 2. That's all good. J. Well, line 1 equals lines I. Can they be equal? Lines 2. J, there we go. And we go. We want an intersection. And I'm guessing it's talking about the x-axis here. It's not talking about the y. Because the x does equal time. Oh, no, it does have... Okay, let's have a look. X and y positions at least 7 and at most 27. Oh, so for both, right? So that's correct. Okay, great. So we're going to write a function. Solve, call. Well, that can't be solve. Linear algebra, let's call it linear algebra, and it returns the solutions, which will be, oh, can I do an anonymous struct there? Oh, I don't know if I can. Const solution equals struct, that is 028 y and a z, and actually that can be question mark solution, probably an error in there somewhere. Line 1, which is line 2, which is also a line. So back to Algebra where we did some maths. What we're going to do is we're going to take the gradients. We're going to find gradients. Var m1 equals line 1 dot the change in y over the change in x. Ooh, we probably want to make these floating points. Ah. Max int by float 128. You know what, we'll leave them. And yeah, because these can be floating points, so int to okay, let's do I128 go F128. Div exact, the numerator is going to be line 1 dot dy, line1 dot dx, m1, m2. Yep. And what did Algebra say again? Yeah, here's the inverse. So it's going to be x and y is equal to the inverse of this, which is this, and then AB. AB is, so I'm going to do bar A there is y1, which is a point, one of its starting points, minus the gradient times x1. So equals y minus line1 dot, oh actually m1 times x1, so line1 dot x. Yes. Ooh, there we go, and that's B. And then there we are. So bar x equals, so inverse matrix equals, so actually what we're going to do is if m1 is equal to m2, return null. Okay, otherwise the inverse matrix is equal to 1 divided by, actually div exact, it's going to be 1, and then it's going to be, which one? m2 minus m1 times oh, so it's going to be, oh wait, I think this is kind of unfinished a little bit, because we're going to then have to time stuff through. So yeah, it's going to be that times AB, which is equal to A over m2 minus m1 minus B over m2 minus m1 x, y, and over here at the bottom, so we did that, and then we're going to do A m2 over m2 minus m1 yep, minus B m1, yeah, minus because of that, m2 minus m1. Yes, so this is actually exactly what x and y is. So, ooh, there's a lot of stuff. So, delta m is m2 minus m1. Delta m, so not the inverse matrix, we're going to go straight into x. So it's going to be A divided by diff. Wait. So div exact A and delta m minus div exact minus B. Oh yeah, oh there's a minus there already, so don't need that. And then delta m, and then y is going to be something very similar, but we do we times the A by m2 and the B by m1. We should get these. So then we do a return solution where dot x equals x dot y equals y dot z equals 0. well, eventually it will be something, but in your Algebra 2D, there we go, we called it that. Do we compile? We do not compile. Why don't we compile? Reached and reachable code, called from here, expect vector integer. What do you mean unknown? You know what this is. What does div exact do? Expect a vector range, type sub with. Oh wait, can I? Oh, float. Are we serious? This is so annoying. Oh my god. Okay, I need a Zig learn book. Yeah, this is where other languages would really come in clutch. But alas, float. Can we not do takeaways from float? Ugh, okay. Okay. Set float mode optimized. Okay, I need to. So, a little tutorial on Zig floats. I don't really know what I'm doing, but let's find out together. 5.123. And we have B, and we have expect, which comes from stand.testing.expect. We have try expect A minus B equals 0. Zig test day 24, day 24. Okay. But this doesn't compile. Why? Is it these here? I'm gonna say just return null here. Just in general. No. So is it you? Is it this? What is happening? I don't know what's happening. Is it this? Excuse me, but what? Oh, is it you? Is it this? Okay, I mean, I can keep you F128 as I128. And then, I mean, here we can play with the types for sure. Oh no. Okay, we can play with the types. Div exact. What was it? Float takes in A, which is an I128, returns an F128. Return at as F128 int to what was it? Float from int of a. So we're gonna do as floats. This can stay. That can stay as is. Oh no, it cannot. It cannot. As floats, because we could end up with this. So you have to wrap them all in as floats, basically. Yep. M2 is already a float, so it shouldn't need it. A lot of as float calls. So M2 is a float. It's F128. You should also be F128. Let's help the Zig language server a little bit. How do you not know what you... Come on, man. You definitely know. Can I not subtract some floats? So A delta M. Yep. That should be good. Okay. I mean, we didn't actually do anything, but we're going to solution equals linear algebra 2D. Actually, it's not a try, so don't need any error handling there. Between line 1, line 2, if sol s, we'll do a continue, otherwise we print no solution. No, oh god, not you. Prints x, y, new line, s dot x, s dot y. And this is where we see if we did our maths correctly or not. What's this, what's this, what's this? Ooh, solution. Yeah, well, you're gonna be an F, wouldn't you? Right, select this, change to F. I wish it didn't do that. 1.2, 1.3, no solution for some of those. Between, wait, what are those top two? Is it these two, the top two? 14.3, 15.3? Oh, that does not look great, does it? Oh, it doesn't either. I don't understand this. This goddamn notation very well. Zig print float as int, kind of. Zig print float precision. Oh god. We can do, let's try standard.fmt.float format float decimal. Print a float format. Yep, let's try that. What do you do? So I need to do a try either way. Value any type options, and I think everything else is basically not really relevant. Can I do that? So an options is just going to be empty. Wait, what was that? Stack Overflow answer and formats. Error printing float. Okay, how do I print a float? Hold on one sec. Well, I think maybe we are printing them a little bit weird, but you know, it's okay. A really good indicator will be that no solution one. See when that happened. So no, I don't need to try that. Yeah, there's no value there. There's no error. So that will be top 2, then bottom 1, then and back down. Then it will be 18 in this one. 18 and 20 doesn't have a solution. Oh, okay, we are right. I think we are right. Okay, so we do solution, and we go if s dot x is bigger than lower and x dot y, s dot y is bigger than lower and s dot x is smaller than higher and s dot y is smaller than higher, then part 1 plus or equal 1, and we continue. Otherwise no solutions. Okay, what is this? Must be const or comp time. Okay, we'll make you const. There we go. You happy? I didn't print. Print part 1. The answer there is 5. Oh, future paths. I'm right. Future paths. So, yep, inside the test area. That one's outside the test area. Wait, I get 5? There are 5 interceptions. Okay. Is that correct with this? So 1, 2. No. 3. 4. Pass crossing the pass first and B. So I think we need to see about the past or the future. Oh, how do we do that? How do we check? Oh, wait, that's easy. We continue our and statement and we say and s dot x, solution dot x, the solution dot x has to be bigger than line 1 dot x. Oh, is that right? Ooh, I'm not sure. Then L2 dot x. Oh, I don't actually know. Okay. F128 equals add float from int of line 1 dot x, fx1, fx2, line 2. Line 2 dot x, about fx1, fx2. That gives me 1 now. Let's get rid of those. Okay. I'm going to say I and something, which is going to be I and j there. 0 and 1, 0 and 1, 0 and 2, 0 and 4, 1 and 4, 2 and 4. Is that consistent? 0 and 1. Yes. 0 and 2. Yes. 0 and 4. Or this one is outside the tesseract, and then 19, 29, 19, 29. Yeah, that's good. And 1 crosses with 12. 1 and 4. Wait, is that 4? 0, 1, 2, 3. No, that's. Oh, wait, we're missing this one? What is this? 12, 31. Oh, right. Oh, cross outside testing. Yeah, that's fine. 18 and 20. Yes, 1 and 4, and then 2 and 4. 2, which is the 20, 25. And what's this last one? 12, 31. Oh, yes, yes. So when there are intersections, what I'm going to do is I'm going to print line 1 x and y, because I need to understand this a little bit better. I'm pretty sure obviously it has to do with the velocity, right? Whether you're going upwards or downwards. So it will depend on your gradients. But let's investigate. So the ones that should be in the past are 19 and 2019. So that will be this one and the last one. So 0 and 4, these ones. So we did not print the solutions. That's great. So yeah, we did not print the solutions because I have no idea what those are. What the solutions? I'm gonna floor the solutions. Solution at floor var sx equals at floor. Let's make you a I128 or something. Floor of what do you do? Hold on. Int from float. Does this work? All right. Int from float. So s dot x, y, sx, sy. So 0 and 4. So 19, 13. The solutions happen at 21, 13. Oh wait, God, this is easy. This is easy, but I need Excalibur to see this stuff. So, given that we have some intersection points, right? So we have 2 lines like this, and then 1 like this, and they cross right there. Right here, what we need to do is we say, right, the starts are here and maybe here or something. So it's not good enough to check. What I need to do is, given the x value of the solution, and whether there is a negative gradient or not. Yeah, if it's positive and the y is less. If positive and y is less than start, then yeah, okay, good. So I can actually add that onto a couple of things here. I can do part function is negative, takes in a self line, and what it returns is a boolean. Return whether, so if it is negative, it is dy is less than 0 or x, or oh, we can't really do an x or though, can we? Return. Oh my god, I am silly. Return as float self dot dy minus as float self dot dx is bigger than smaller than 0, because we're asking if it is negative or not. Okay, so if line 1 dot is negative and s dot y, if it is negative, right, so if it's like this and the start point is here and the solution is here and the solution is bigger than line 1 dot y, oh god, the fy, which is an f128, which is at float from int line 1 dot y, 1 2, god, stop doing that. If line 1 dot is negative, is bigger than, yeah, so this implies that it's outside, or line 2 dot is negative and s dot y is bigger than fy2. fy1, if so, continue. Right, that makes sense to me. You compile, but now you don't even get me that much. 4 is not right. So which ones are we still selecting? 0 and 4 we're still selecting. So 0x, well, so it's going to be negative gradient. 0. Oh, negative gradient. What line 2? Line 2 is 4. 20, 19, 1 minus 5, so it's going to be negative gradient 2. So that's 0, 4, which is 19 and 20. Crossing the path first on A. So if line 1 is negative, I'm going to print some stuff. Print line 1, line 2, just to make sure that I've implemented those ones correctly, because there's a chance I might not have. The 0 and 4 is 0 and 4. Line 1, false. is negative, false. No, it must be true. So line 1 is 0. X, Y. No, you are negative. So this is wrong. What did I do wrong? Oh god, I'm stupid. Div exact. Yeah, this is like super overkill, but yeah. Really? Come on, man. What am I doing wrong? So it's saying at 0, 4 that line 1 is still false. And line 1 is 0, 19, 20. No, that's fine. Bro. What? It's negative. For 0, 4 is the one I'm more interested about. 0, 4 is negative, which is a minus. Oh, and maybe it's like a really it's not a really small minus though, like. Okay, you know what, let's just like, okay, so return self.dx, so return if self.dx is smaller than 0 and self.dy is smaller than 0, then you return false because they are both negative, so they're going to make it positive. You are not negative. Otherwise, return self.dx smaller than 0 or self.dy is smaller than 0. Zero 4 still appears. Oh no, that's good though. It's true there. And if it's negative and the solution is bigger. Wait. Yeah, so those are both negatives there. 0, 4. The solution is. Oh, maybe it can't really do that super easily. I'm going to say smaller than or equal to and see what happens there. Huh. Well, that's unexpected. So they're just equal. A lot of them are just equal. Like, that doesn't seem right. 0, 1, 0, 2, 0, 4. I'm just, having some trouble. So it starts in 1913. I don't want it to print this goddamn notation. Zig print float as decimals. D, is that it? For double maybe? No. F64, oh, okay, I mean fine, as F64. As F64. It truncates. Oh, come on, bro. Oh, that's Rust. That's not really what I want, is it? D colon 0.3. Does it still expect F64? God. For Sx equals F64 equals add truncate S dot X. Truncate only works for integers. Truncate reference type at float. Converts from one float type to another. Yeah, that's exactly it. Okay. So for 04, we have, whoa, wait. 2113. Ooh, that is not correct. You are doing something fucky somewhere. Because that can't be right. Like obviously you cannot have exact solutions. I'm gonna take that top one, just the top, those three. Oh, come on, this would be so much easier in JavaScript, like, or any other language. This is just hard in Zig. So 12, 13. So that's not even close. It's just luck. Oh God. What is M1? Then A. Okay, I'm gonna print A. Point 3. Then I'm gonna do float cast of delta M. Okay. A. It's this. I'm pretty sure it's this. Give exact of A, comma, delta M. B delta M. Is it multiplying? That's being weird. Float multiply. Zig multiply floats. Floating point operations. Yep. Okay. So, I mean, all right. Look, there's actually only going to be some cases where this is needed. So I'm going to get rid of as much of it as I possibly can, because the division between integers is, oh god no, division between integers is not always an integer. I was going to say something quite silly there. But A, no need be floats. Okay. B, no need be floats. Is it the... I mean, I'm so confused by so much of what is happening right now. Oh, come on. Yeah, sure. Just go back. Okay. So, delta m is 1. Delta m is m2 minus m1. m2 is 1. And that there y over m2. So it's going to be minus a half. So m2, which is 1, minus a half. That's not right. That's... Oh, what the hell, man? Oh, I gotta say, I'm going a little bit. What? Just, bro. Test. M1 equals 0. How's that? Do you equal 0? You do. Oh my god. Come on. You are not 0. You are not 0. What is this happening? Exact division. I don't... For a function that returns... Exact division. Call it guarantees dominates not equals 0. Oh wait. It's just a function that we're just messing up brutally. Div... Is it you? Div exact to div trunk? Zig divide floating points. I mean, what if the compiler will tell me to go away, but I'm pretty sure, what if I do that? There you go. Well, that just works. What am I doing then? Why do I need this? Why? I swear I needed this before somewhere. Oh, that was fun then. Some time well spent, you know. Just really fun. I really enjoyed that. Okay, well, you know, it's not bad. Some brackets minus SB as S1 divided by this. There we go. There's a solution. I think now we got it right now. But they do intercept, so I'm not sure what this is about. So they intercept, very good, and then you don't add anything because L1 is negative and L2 is not. L2 is not negative, yeah. Mm, mm, mm. So if line 1 is negative, now line 1 is negative, and S, the solution, 14.3, no, 15.3, is bigger than the other solution, then that might have happened in the past. Okay, so it happens at 15 and you have a negative gradient. How does that work? I'm confused now. Oh no, because the change in y. I'm a little bit puzzled by that one. Okay, how do we determine they are made in the present? We look at the x and we look at this. If this is a positive number, maybe that's it. I don't need L1 dot. Was it negative? We say L1 dot dy if L1 dot dy is smaller than 0. Smaller than 0, and yeah, dy is smaller than 0. Okay, we have solution. Actually, I'm going to just comment these out for now, just in case. 3. Is 3 the answer? 2. 2 is the answer. Adding. 3 is not the answer, so that means we're getting 1 extra. So for this top one, L1 dot dy is smaller than or equal to x, smaller than or equal to 0, false, doesn't go there. That one there is, no, this is just wrong, this is wrong, this is just not correct. How the hell do I determine if you are, oh my god, this is so easy, this is just comically easy and I'm struggling so much. Look, this is actually a time where we bring out Desmos. Oh, come on, man, my brain. Just work, please work. You're not working. Y minus 13 equals x, 1 over 1 over minus 2 x, take away 19. And we do y minus 19 equals minus 1 over minus 1, which is just 1. No need to write that, but so yeah, there's the intersections, but they start at so A, which is red, that's 1913. Is it the x-axis? Starts there, 1913, and the blue is 1819. Wait, how is this inside? They will cross inside the test area. And then for this one, they crossed in the past. So actually, let's examine this one here. So it is -5/1, and the x, the y 20, and then this here is 20. So these ones. No, sorry, this one here. So there's the intersection. But then hailstone A, which is the red line, starts at oh god, is it the other way around? Maybe it's the other way around. Oh, actually, let's do some redos. I cannot do a redo, why not? dy smaller than or equal to 0, smaller than 0. Dot dy is smaller than 0. Now you get 2. Yeah, maybe. Maybe. Let's comment. Let's get rid of those actually. This is lower. This is higher. Let's grab the input. Wait for it to crash on me to go to sleep. Yeah, okay, well. Yeah, it's because I'm not actually determining. I still don't understand what the hell is happening with these. I just need my brain to work a little bit. Okay. No, not Desmos. Oh, I closed Desmos. I want to keep that one open. That's just something else. Okay. Where is... oh, I closed it. I closed Desmos. No. Okay, let's just try and understand. Let's read. We've been stuck on this way too long when we actually had a solution like half an hour ago. Okay. Think. John. Stop it. Let's go. Let's think. These cross inside the test area. These crossed outside. These crossed in the past. So 0 and 4. Which is 19 and 20. This one crossed in the past. So here, what does this mean? So we're going to increase the y each time. Is it that the x has to be bigger? So the x is 21. It starts at 19, so it goes forward and then down a little bit. Goes down a little bit, I think that's fine. Then for this one, -5, so it's a pretty steep gradient. So it goes down. But here it says hailstone's paths crossed in the past for hailstone A. What is that? I still don't really understand. Each line of text corresponds to position of velocity. The position indicates where the hailstones are right now at time 0. Okay. So if you have this initial position of 1, 2, and you have vector minus 1, 2, that means you start off 1, 2 around here, and you're going to go down. You're going to go down 1, up. No, you're going to go to the. Your gradient is negative, basically. So 2 over minus 1, your gradient goes like this. Right, so 1 over, and you're going to be at 0, x 0, and 4. Oh wait, this is kind of inverted. Oh, that's why our thing worked, because it was inverted. Yeah, like solution kind of did work, but not for the reasons that we thought. Like we're still getting 2 like this, right? I'm gonna adjust things a little bit. So if I redo, I get I get 0. Oh, because of these. It was a really big number and another really big number. Yeah, so I kind of understand, because it looks like they're kind of going backwards, right? In the it's really weird for me to explain that, but they're kind of going backwards. I think that was my last submission, but if I make it equal. Oh no. Bigger than or equal to there as well. 346, 346. 346. Are we sure 3406 is not right? It's too low. Oh, come on, man. Come on, come on, come on. All right. So I basically had to turn off the camera for a bit because I was just a bit like weird. So basically, I just have to figure out what the goddamn time is, which is the x-axis. I couldn't figure that out for some reason. So you take the point minus the, you take the point of the intersection and you minus it by, basically this is the rearranging of the formula. Right, y equals x plus, the rearranging of the formula, which is the point x plus m of something, right? mt, which is time, I suppose. And that's just to rearrange. Actually, it's a two-round equation. Yeah, that's so easy. I don't like, my brain was just fried by thinking about y equals mx plus c and didn't really think about anything else. But anyways, here's the big decision. That's a really big number. Okay, good. All right, very nice. We got it. Upon further analysis, it doesn't look like there's any hailstones will naturally collide. Great, no magical winds then. It is up to you to fix that. You find a rock on the ground nearby. While it seems extremely unlikely, if you throw it just right, you should be able to hit every hailstone in a single throw. You can use the probably magical winds to reach any integer position you like and to throw the rock at any integer velocity. Now, including the z-axis in the calculus, if you throw the rock at time 0, where do you need to be so that the rock perfectly collides with every hailstone? Whoa, okay. You can use the winds to reach any integer position you like and to propel the rock at any integer velocity. So I can do anything basically, including the z-axis in your calculations. If you throw the rock at time 0, where do you need to be so that the rock perfectly collides with every hailstone? That's not the rock. Due to probably magical inertia, the rock won't slow down. In an example above, you achieve this by moving to position 24, 13, 10 and throwing the rock at velocity this. Wait, are you asking me to solve for... Whoa, excuse me, what? So basically, this might be it. This might be time to call it, but I'll give it a small go. So you have a rock, and you throw it, and you want to hit every single one in a single throw. Hit every single one in every single throw, but you can throw it at anything, but it won't change direction. If you throw the rock at time 0, where do you need to be? Yeah, so you need to throw it perfectly. You need to throw it in a specific circumstance such that it will hit everything. So we need to find some formula that can't really be brute forced, such that it just hits every single one at some point. So we need to find a solution for every single equation. Oh God. Oh my Lord. This is like... We have 6 equations. For the example, right? For the input, we have many more. We have 6 equations. Oh, we have 6 equations. And we want to find a solution. Oh my. This is a really, really big... Oh, this would be a huge matrix if done that way. I think this... Oh God, what time is it? It is 30, yeah. As is customary, I suppose, I'm calling it. I mean, I have some ideas, but I cannot solve this on my own, I think. This will require a lot of searching. And yeah, I'm not putting you through that. I'm not putting me through that for right now. Have a good one. Merry Christmas, everyone. And maybe I will see you today. I'm not sure. I'll attempt it. But either way, I can only do part 1 next because I haven't done all the other stars. Might be time to go back and collect some of the other ones. Anyways, thank you so much for watching, and thank you for all the support so far. See you later.